Good afternoon, everyone. My name is Dennis Angeline. I'm a lead program manager on the Common Language Runtime team. And we're going to talk about advanced deployment issues and how people go about deploying assembly, setting version policy, and build applications or components that can be used in a side-by-side fashion. So if there's anybody here for the interop talk that I referred people to yesterday at this time, I was incorrect in stating that it was at 1 o'clock. That talk is actually being held at 2:30 in room 403 AB. So if you're here for the interop talk, that's not what we're doing right now. I'll be in 403 AB talking about interop in an hour and a half. So how many people got XP CDs here? Good number, huh? Was the line long? Well, I wasn't up at 7 o'clock to see it, so. Oh, great. So there's enough for everybody. Okay, good. Okay, so let's get started talking about deployment. First off, I want to go over what we're going to cover here today and what we're not going to cover. So this isn't really a basic deployment talk, okay? We won't talk about things like what is an assembly. We won't talk about the metadata. We won't talk about what DLL hell is, because I think you're all thoroughly familiar with that. Those kind of more fundamental issues were covered in other sessions, or were covered at last year's PDC in quite a bit of depth for those that were here last year. And you can kind of pick that information up pretty easily out of the docs that are available in the SDK. So what we will cover today is how you go about signing code and what code signing is all about, what deployment decisions people have to make when they're developing applications and deploying shared code, and how to go about setting binding and version policy for assemblies that you might deploy with your application. Those are really the key new things that the Common Language Runtime provides. There's a number of related talks. Excuse me. Two of them were already held yesterday or Wednesday, and one was held earlier this morning. The one that was about deploying client code was held yesterday. Ideally, that talk would have been held after this talk, but due to logistics, it had to be held before. But that really went into some other issues on why it is safe now to deploy client code to client machines. That was a talk that Stephen Pratchner gave. There was another talk this morning about managing applications throughout the development process that Michael Day gave. That was at 8:30 this morning. There's this talk now about advanced deployment and version binding policy. And then there's another talk later on, or tomorrow morning, about deploying code over the web and client-side or download of code to clients over the web. So those are just some interesting talks that you might want to look at. First off, before we get started, I want to make it clear that we're talking about mostly shared code in this talk. And while that's not the code that everybody builds, there's certainly a large group of people that build shared code. So I want to make it clear what we're talking about here. Applications are typically made up of shared portions and unshared portions. The unshared portion is for most applications, is the exe that you're building. It's the application exe, okay? That application is used by the user, and it doesn't typically expose any objects out to any other exes. It's typically a private application that's just being used by the user. But that application, within that application, you may reference other assemblies or other components, and those components are sometimes shared components and sometimes they're not shared components. There are certainly things that you might use that you get from the system, things like ADO or XML services or Active Directory services, and those are components that would be considered shared components. There are things that you get from third parties, things like grid controls or charting controls or other libraries that you might get from third parties. Those are shared components. They're being deployed by some other vendor and they're being used in a variety of applications. And then there's internal components that you might consider shared as well, things that contain your business logic or maybe data access functionality that you build into your application. And so you have these shared portions and unshared portions of the application. We're focusing on the shared portions of the application in this talk. Now typically the shared portions and the unshared portions are built by different developers. Sometimes you call them component developers and application builders, right? We're talking to both of those audiences here, but we're going to focus on how you deal with the shared portions of your application. So we'll start off by talking to those of you that are component developers, those of you that are building the components that are going to be shared. How many people would kind of fall into that category? And a lot of people will fall into both categories, okay? And later on we'll talk, in about 15 minutes, we'll talk to the application developers who are actually going to take these components that the folks that just raised their hand built and then deploy them within their application. So if you're building shared code, one of the first issues that you'll come up against is how do you identify your code, and how are you going to make your code identifiable because it is shared. It is going to be put into a location or locations where it can be mistaken for other code. So you need a way to uniquely identify the code or the assembly that you're deploying. And the way we do that is with strong naming. You may be familiar with strong naming from other talks. But essentially, what a strong name is, it's a way to identify an assembly. The strong name contains a name, a publisher key, a version, and a culture. And that strong naming is done by the assembly or component builder that's building this shared component. So it's something that's done by the component builder at development time. It does not provide any means of authentication, though. That's one thing to be really clear about. By signing your particular assembly, you are not stating your identity or providing a mechanism for anybody to authenticate you. You're just providing a way to uniquely identify your assembly. It's used by the runtime, those strong names, in a variety of situations. It's used to do version checking because that version number is a part of the strong name. When we do binding from that exe to your shared component, we're going to do a lot of version checking and make sure that you're binding to the correct version. It's used to enforce binding policy or version policy, and we'll talk about that quite a bit later, where we're actually redirecting from one version to another version. It's used to provide security evidence because at runtime people may state, or applications may state, that they only want to use use code provided by a certain publisher, and we'll use that publisher key within the assembly to enforce those security requirements. And it's also used to prevent tampering or spoofing, to make sure that nobody's tampered with your assembly once you deployed it. It's signed and cryptographically secure, and it makes sure to make sure that nobody can spoof your assembly, so somebody can't go out there and replace your assembly with another one that does some malicious stuff to the user's machine. So we have these strong names. They're used by the runtime at execution for a variety of purposes, and they're put there by the component developer. So just a bit about the identity, or the assembly identity of this strong name. It consists of a name. It's typically a relatively short name, but it can also there's also a namespace within your assembly, and the namespace and the assembly name are independent. Okay, you can have an assembly, for example, MS Core Lib. If you actually look at the name of MS Core Lib, the actual assembly name is something like MS Core, or MS Library, Core Library, or something like that. But the actual namespace can be quite long. There's system.runtime.interop services, and you have all these namespaces within that assembly. So the namespace is independent of the assembly name. Most people typically try to use the same namespace and assembly name, but that's not a requirement at all. The namespace is completely independent from the assembly name. The publisher key that is actually embedded in the assembly is actually just the public portion of a public-private key pair. You can create that key with a utility called SN. We'll show you how to do that in just a bit. In that assembly then is the public portion of that public-private key pair. Of course, the private key doesn't get deployed at all. The version number that's encoded in there is a 4-part version number. They're customarily used to indicate the major, minor, build, and revision number of that assembly. There's no semantics applied to the version number, though. They mean absolutely nothing when it comes to how you actually apply policy or anything like that. How you use those numbers is completely up to you. The fact that we indicate major, minor, build, and revision is just kind of a customary thing. So don't imply anything from the version numbering that you use. And it also contains a culture typically for resource assemblies that are containing information that's that can be localized. You can also have a culture within your assembly to say this is the Spanish version as opposed to the English version. So using that publisher key and that name and version and culture, we're able to uniquely identify assemblies. So we can have a variety of assemblies installed on a user's machine, all containing types with the same names. And that assembly identity is really what allows us to uniquely identify the specific types. So for example, I can have 3 assemblies here that all contain 2 types, one called widget and one called gadget. And you'll notice that they're created by 2 different publishers. By 2 different publishers, and the assemblies have different names. So up here I have an assembly called MathLib, and down here I have one called AcmeLib and AcmeLib. So these are different. These are created by the same publisher, the first and third, because they have the same publisher key, but they're different versions, and this is created by a different publisher. So you can see that even though the types have the same name, they're all uniquely identified because we use the assembly identity to qualify that type, or to qualify the type name. So during compilation, when you're actually referring to another assembly, one of the key features of the runtime and the binding mechanism is how we actually capture that version information or assembly identity of the dependent assemblies and then bake that or compile that into your executable. So for example, in this case I have an assembly called MathLib and this assembly called AcmeLib. Imagine these are just 2 assemblies. They may be used by another executable, or MathLib could have even been an executable itself. And in this MathLib, I actually reference the AcmeLib and I create a new widget object. Well, when I compile that, that reference to the widget object actually causes the compiler to go out and take that strong name or that assembly identity and pull pieces of that or a part of that into the actual assembly that I'm building. So I can see that it actually puts a reference in the assembly that I'm building that points back to the assembly that I'm referring to. So you can see it takes AcmeLib, it takes the version number and the culture, pulls it up here, puts it into reference for the assembly that I'm building. And it actually takes a token of the publisher key. So the publisher key is a 128-bit or 128-byte key that's actually put in here. We actually only pull 8 bytes of that out and put it in the reference, and that allows us to verify that we are indeed binding to the correct assembly. Now, I thought I changed this on the slides, but apparently I didn't. But I don't mean to imply that we take the first 8 bytes of this publisher key. These are the same here. In fact, they're not the same in practice. There's actually a mechanism that we use for getting a token, and that token actually gets baked into the reference. It's not actually the first 8 bytes of the publisher key. So when do we use strong naming? Now, strong naming is used to uniquely identify assemblies, and so it would be very wise for those of you that are building shared components or any kind of component that's going to be redistributed to sign your assembly, to sign your component. You want to be able to uniquely identify it. One key reason why you want to be able to uniquely identify it, if for no other, is so that you can fix it later on when you identify problems with it, right? If there are problems and you have it strong named and you can identify the assembly, you can apply patches, you can install new assemblies that override those, you can set binding policy, which we'll talk about in a minute, that will redirect users from the old one to the new one. If you don't strong name, there's really no way to identify your assembly on the user's machine other than by file name. And so it's a very good idea to strong name your assembly if you're building shared components or shared code. So in general, you want to strong name assemblies whenever they're being used by several applications. Certainly when the code's being redistributed. So if you're going to take your component and give it to application developers and have them redistribute it, you want to make sure you're strong naming. If you want to use that version checking that I'm talking about, or that I'll talk about in a minute, if you want the runtime to ensure that the applications are binding to the correct version, you need to strong name your thing. That's where the version number goes. And I should point out that you cannot provide only a portion of that assembly identity. You can't just provide a version number without a public key. It all goes together. You have to provide all 4 parts in order to strong name your assembly. And so if you want the version checking, you need to have the strong name. If you want to apply binding policy, which gives you the ability to redirect from one version to another, you need to be able to strong name your thing, or you need to have your assembly strong named. If you want to prevent this tampering or spoofing that I'm talking about by having that strong name verification done, you need to make sure your assembly is strong named. So in general, if you're deploying shared code, you want to strong name your assembly, absolutely. There are a couple things to note about strong naming, though. If it's not a shared component, for example, your executable, okay, or maybe some DLL or assembly that you're creating that you don't intend to be shared, it's just used with your executable, maybe has some utility functions in it. If it's not intended to be shared, there's absolutely nothing to be gained by signing that assembly, okay? It's not that there's anything wrong with signing it. If you want to just go ahead and sign everything, that's perfectly fine. The signature in an unshared component, though, will just have no effect, will serve no purpose. So there's no sense in signing things that aren't shared. And also, it's important to note that signing or strong naming is not a means of authentication at all, okay? There is nothing in the runtime that does authentication using these strong names. Now you can, in addition to strong name signing your thing, provide an authenticode signature, which is for authentication, but these strong names do not provide any sort of authentication at all. So that's something that people get confused about all the time. They think that in order to get a key to do the signing, I need to go to VeriSign or some signing authority. That's not the case. These keys are not used for authentication in any way. So how do I go about strong naming an assembly? First off, we need a key file. We need some store for the keys that we're going to be signing things with. Now, they're typically, in every case I've seen, stored in a key file, but they can also be stored in hardware. And we have utilities to actually support pulling a key from a hardware device as well. But typically what people do is they use a utility called SN for actually generating a key pair. Now you can use SN-K, like I'm showing here, to generate a key pair and output it to a file. In this particular case, I'm outputting it to keypair.snk. SNK is the customary exception for a key or extension for a key file like that. If I do SN-K, it'll generate a key file that contains the public and the private key. If I then want to pull out just the public key out of that key file, I can do SN-P and give it the name of the key file and another file name where I want the public key portion stored. Now this is important because you don't want the private key that you're going to be doing your signing with to be handed out indiscriminately. You probably don't want it handed out to developers within your organization. Customarily, the public key goes out to the developers, and the private key gets stored in a vault somewhere where only the legal people know how to get to, right? So you don't distribute that private key out to developers. So what you would do is use SN-K to generate the key pair, use SN-P to pull the public part out of there, and then you would retain both of those files. You would give the public keys to your developers, and you would retain the public-private key pair separately in some vault or secure place. You then sign your assemblies by putting an attribute on the assembly, an assembly attribute. You can just say assembly key file and give it the name of the public key or the name of the key file. That'll actually do the signing as you're compiling. Now, if you're using Visual Studio, just in every project that you create, it'll create a file called assemblyinfo.cs. That assemblyinfo typically has these attributes in it all set to null. And so you can go in there and just put the name of your key file in, and that'll sign your assembly. You set the version number for your assembly in the exact same way. You can use the assembly version attribute to set the version number. Now you typically set that in that assemblyinfo.cs file or .vb file. But you can just take those attributes and put them right in another file. There's nothing special about assembly info. There's also this notion of delay signing. What delay signing does, and you can use the assembly delay sign attribute here set to true. Typically what most people do is they set delay signing equal to false during development time. And what that means is basically that we're not going to do that cryptographic signature part of the signing at development time. So by setting this to true, what it actually does is reserve a blob within your assembly for that cryptographic hash to be put in later on. Okay, so you can imagine it's compiling, setting aside a chunk of space in the assembly for the cryptographic hash to be put in later on by some folks over in legal. So if I set that to true, it sets aside that space for the cryptographic hash to be placed, and later on I can actually sign it with the real private key using SN-R to actually do the signing of the assembly. That'll do the encryption of the assembly, or take the bits of the assembly, build a hash, use that private key to actually create that hash, and then embed that hash in the blob that was set aside at compile time by using the delay sign. If I don't use the delay signing, then it never reserves that blob, and I won't be able to do the re-signing later on. So the way you would do it in practice is set delay signing to true when you're about to deploy your thing. Build your project, build your assembly, and then go through a second step and sign it with the real private key. And that would typically be done by the person who has access to that private key pair. For playing around, for toying around, what most people do is they create a key with SN-K, reference that key in their assembly key file attribute, and that's that. It's signed. But if you want to be legal about it and you want to secure your private key, you do it the way I just described. So a bit about strong name verification. So what does that cryptographic hash actually provide? What we do is when we load an assembly, we verify the strong name on that assembly to make sure that it hasn't been tampered with and to make sure that nobody's spoofing that assembly. And how we do that is we take a cryptographic hash of the entire assembly and actually embed that hash is created with the private key and actually embed that hash into the assembly. And that's what I was just talking about on the previous slide. At load time, when somebody actually builds an application then that references your assembly, when that assembly is loaded, we actually take that hash, decrypt it, and using the public key that's provided in the assembly, in that assembly identity there, we decrypt that hash, and we take the bits of the assembly and rehash those and make sure that those hashes match. If the hashes match, then we know that the assembly hasn't been tampered with, and we know that nobody's trying to spoof this assembly. They couldn't have signed it and couldn't have created an assembly with your identity because they don't have your private key pair, or your private key. So by doing that verification at load time, we can ensure that the assembly hasn't been tampered with. And depending on how you actually deploy your assembly, we'll talk about when that verification gets done. And there's some circumstances it's done on every load, and other circumstances you can avoid that. So that was focused at component developers. And what you should have gotten out of that is to strong sign your assemblies if you're redistributing them or sharing code and developing and deploying stuff to application developers. So now let's talk about the application developer and what he's going to do with the code that he just got from this component builder. So how many of you out there would fall into this category, application builders? Okay. And how many of you are in both categories? Okay. So you got this piece of shared code, this assembly that somebody provided for you. You either got it from some third party, maybe it's something that Microsoft provided as part of the system. Maybe it's something that some guy over in a department next to you created, and he wants it to be used throughout the entire company. You got this shared thing. It's signed because he wants you to be able to uniquely identify it, and you need to put it in your application now. You need to use it from your application. So realize that it's the application author that's going to decide how this assembly gets deployed. It's not the component developer that decides how it gets deployed. The component developer had the choice of whether he can sign it or not, but he has no control over how it gets deployed. It's these application folks, or application builders, that are actually going to deploy his assembly. So there are different alternatives or different mechanisms for actually deploying this code. You can deploy code in three places, typically. You can deploy it in an application directory, which is just a directory that you create in the file system and deploy code into that directory. You can deploy it into what's called the global assembly cache, which is a repository for storing shared code that's available on a machine. Or you can deploy it someplace else on the machine that you refer to via what we call a code base. Now the unshared portions of your code are going to be deployed in the application directory, without a doubt. These are the parts of your code. This is the XE. These are the private libraries that nobody else is using. Those get installed into the application directory. So you create an application directory, typically under program files or whatever, you put your executable there, you put any unshared or unsigned assemblies into that directory. And so then there's a question of what you do with these shared things. Of course, you want to be able to want other people to be able to get to them, or you may not. If they're shared, you typically do want other people to be able to get to them. So you need to decide which of those places you're going to actually put the shared code, whether you're going to put it in the application directory, in the global assembly cache, or in a code base. So let's look at putting it in the application directory first. So in this particular model, I would take my private stuff and my shared assemblies that I got from this component developer and put them in the app directory. Well, one key advantage of that model is the simple deployment mechanism. So what this gives me the ability to do is just simply X-copy the bits from some disk, some file share, some other place right into a directory on my machine. Really compelling for web apps. Okay, I don't want to have to go through any install or anything like that for web apps when I'm deploying shared components. I want to just take them, drop them into the bin directory, for example, under my application, and have them used there. I don't want to have to do any registration or any kind of other installation steps. So that's kind of compelling. The other somewhat compelling reason to use the application directory is that the code is somewhat private. Now, I don't want to say it's totally private, but it's semi-private if you put it in the application directory. What I mean by that is the binding mechanisms that we use, as we'll see in a minute, typically look in the application directory or the global assembly cache when looking for assemblies. So other applications that aren't installed in your application directory cannot get to the assemblies that you have in your application directory. In other words, each application is isolated. The assemblies that are installed in that directory are private to that application, and nobody else could reference them. Now, with that said, somebody could create a code base that points to your application directory and reference things in your application directory, so they're not totally private, but they would have to know that your code is there, and they would have to go out of their way to actually reference them. Of course, somebody could just copy your assembly out of that directory into another directory, but by default, it's not going to be used by anyone else. It's somewhat semi-private there, so you have that assurance. Some of the disadvantages of putting things into the application directory. First off, the assemblies are located by file name alone. You dump files into the app directory. There's nothing for us to look at other than a file name. So the way the binding actually works is we take the name of the assembly and we look for a file with that name. If we find a file with that name, we load it, and then we verify the signature at that time. We verify the publisher key and the version and the rest of the information. But the binding itself is done strictly by file name. What that means is that you can't have multiple versions of the thing installed side by side because you can't put two files with the same name in the same directory. It also means that servicing, if you need to patch that assembly or make fixes or updates to that assembly, they need to be done in place. You need to overwrite the file with the patch. Once you overwrite the file, you've lost the old thing. If the user wants to go back to the old one, they have no way of going back. Now, you could, of course, back up the file and then create the new one there and tell them to restore the backup or delete the file and copy the backed up one over the assembly if they need to go back. But there's no built-in mechanism for patching things or providing a side-by-side install. You simply overwrite the file. Another disadvantage of using the application directory is that it might be difficult to locate things that you want to service. So suppose you do have an assembly that you want to fix, and you have users that have deployed it in a private fashion in their application directory. One mechanism that you could use is to deploy this fix or this patch into the GAC, which would supersede assemblies that were found in the application directory. But if you did actually want to go out and remove the assembly from the user's machine, it would be somewhat difficult because you'd have to actually know where that assembly is on all those application directories. About the best you could do is search the hard drive for an assembly with a particular name or a file with a particular name. Another disadvantage of using application directories is that the strong name gets verified on every load. So we talked about the strong name verification and how the cryptographic hash is used to verify that the assembly is the one that it was provided by the publisher. Every time you load an assembly out of the application directory, that verification has to be done. So there's a bit of a perf hit there for doing that strong name verification. And finally, a consideration for web applications. If you have 10 web applications, for example, that are using the same assembly that you decide to deploy privately in 10 different application directories, as those assemblies get loaded, we simply load them with a load library, and because the load library path that we provide is different for all 10, I could have the same file loaded into a web server 10 different times and taking up memory for 10 copies of the same thing. Because they come from 10 different directories, the OS has no way of knowing that this is the same exact file, and it won't do any memory mapping of that file to different address spaces there. It'll simply load the same file 10 times, so you get some additional working set overhead when you actually deploy things in an app directory in that fashion. So let's look at the global assembly cache. How many people were at Don Box's talk on Monday here? Okay, what did Don say about the global assembly cache? Does anybody know? He likened it to purgatory. He said the System 32 was hell and the global assembly cache is purgatory. Well, I have to respectfully disagree with my colleague from development. We actually had dinner last night and discussed the merits of the global assembly cache, and I think we see eye to eye, but he may have been a little more harsh on the global assembly cache than I would have liked. I personally think the GAC, or the global assembly cache, is just the greatest thing. The advantage of the global assembly cache is that it supports side-by-side versions. We'll see in a minute that I can have multiple versions, actually I can show you right now, multiple versions of the same assembly installed into the global assembly cache at the same time. I can have an assembly called MathLive, and I can have 10 different versions of it in there installed at the same time, all side by side. I can refer to any one of those 10. I can have English ones and Spanish versions in the GAC at the same time, and I can bind to specific ones. When I want to deploy a fix or a patch to one of those, I can deploy version 11 right next to versions 1 through 10. And versions 1 through 11 are now in the global assembly cache. If there's a problem with version 11, I have a mechanism to tell my users how to go back to version 10 and use version 10 if they need to. When I put something into the global assembly cache, the signature is verified at install time. So when loading things from the GAC, the signature verification isn't done at load time, it's done at install time, and another perf benefit. So no verification done at load time. All verifications done at install time. And that additional working set that I was talking about, because all 10 applications, for example, that are referencing the same assembly are actually pointing to the same exact file out of this global assembly cache, there's no additional working set for actually loading these into memory n times. Each time you load it, it just gets memory mapped into a different address space, and it can be referenced by multiple applications without any additional overhead. Some of the disadvantages of using the global assembly cache, it requires a strong name. I don't think that's much of a requirement, though, because like I said earlier, if you're building something that's being shared, it should certainly be signed, so it needs to have a strong name. It must be installed with a utility called GACutil, or more typically with an installer, and I'll show you in a little bit how to actually build a project in VS that actually has your assemblies installed into the global assembly cache. It's not X-copyable. In other words, you can't just X-copy right into the global assembly cache, although you can drag and drop an assembly into the global assembly cache. It's typically installed with an installer, with an MSI script, or with a utility called GACutil. And the code in that global assembly cache is accessible from any application, so I don't have any way of privatizing my code. If I put it in the GAC, anybody can get to it. Now, they have to refer to exactly that assembly, exactly that version, but if they want to, it's there. They can get to it. And so there's no Xcopy deployment. The last alternative, so I'm pretty high on the GAC. I think that's the way to go, even though Don's not. The last alternative is to use Codebase, a Codebase option. Now, this option is also somewhat appealing as well. I would say this is the second best thing to the GAC, and then using the app directory is the third alternative. Using the Codebase, what I'm able to do is actually just in a config file, I'm able to create a configuration file put it next to my application executable, or in the case of a web app, I can use the web config file. And I can reference a particular assembly with a particular name and give it a URL where that assembly can be found. It's a URI, actually. It can be in the file system, it can be on the web. If it's on the web, it'll be downloaded. And so that's pretty compelling there. I can support side-by-side using code bases because I can deploy multiple versions to different directories in the file system somewhere and then set up a code base that points to each version. So I could have side-by-side versions of an assembly and refer to them uniquely using code bases. And it's compelling that I can download code from the web this way. I can have that code base be a URL that points to some server where my code is stored, and as those references are made to that assembly, the runtime will automatically download that code, put it into what's called the download cache, and refer to it from there. The disadvantages of the code base option are that it requires a configuration file, not much of a requirement. There's probably other things that you're going to want in that configuration file anyway. If you're building any kind of complicated application, you'll probably have a config file sooner or later. And again, the strong names are verified on every load. Okay, so the application developers have to decide where they're going to put the things, and where they're going to put their shared code. And I just gave you three alternatives. You can put them in your application directory, you can put them in the global assembly cache, or you can put them in a location that you specify via a code base. That choice is kind of up to you. I just told you the advantages and disadvantages to each. Let me tell you some things that you don't need to consider in making that decision at all. These are just almost myths of the deployment mechanism that we have. First off, the strong name is verified regardless of where the assembly is located and how it's loaded. If the assembly is signed, if it's a shared assembly that's signed and given a strong name, that strong name is verified regardless of where you put it. So you don't need to say, I need to put it in the GAC so I get strong name verification. It will be strong name verified if it's signed and it comes out of your application directory. So that's not a factor to consider. And that prevents the tampering and spoofing. So regardless of where you deploy it, you'll get that mechanism, that strong name verification. You can use what's called publisher or machine policy, and I'll show you how to do this in just a minute. What publisher and machine policy are the ability to redirect from one version to another version. And you can apply publisher or machine policy regardless of where you install the assembly as well. They can all be installed by non-admin users. Now, Don pointed out on Monday that you have to be an admin to actually install things in the GAC. It's somewhat true. You don't actually need to be an admin to install things in the global assembly cache. But the global assembly cache is in the Windows directory, under the Windows directory, and typically only admins have access to that directory. And so while you don't actually need admin permissions to install things in the GAC, there's nothing that's going on with the registry or anything like that. Because of the fact that the GAC is located in the Windows directory, you typically require administrative permissions to actually get things into that directory. You can relocate the GAC to another location, and then you wouldn't require any administrative permissions to actually install things in the GAC. And regardless of what mechanism you use to deploy your shared code, none of them use the registry for anything at all. So there's never a need to touch the registry or tweak the registry at install time. So those are some non-factors, things that don't even matter when you're making that decision as to whether or not where you're going to deploy these shared things. There's a couple of times when the choice is clear, when you have to use one over the other. You want to use the app directory if the assembly is not shared, if it's some private thing that you don't intend to be shared. If the assembly is not strong name, so you got this from somebody and they didn't strong name it for one reason or another, you don't have any choice other than to put it in the application directory. And if it must be Xcopy, if you really like that ability to Xcopy deploy things, like in the case of a web app, you must put it in the application directory. Xcopy is only supported for application directories. When do you want to use the GAC? You want to use the GAC when you want that side-by-side servicing ability, the ability to have 10 versions of the thing installed on the machine at the same time and redirect the user from one version to another. That's when the GAC makes a lot of sense. So there's three places where assemblies can be stored, and I want to go through the rules that we use for actually finding assemblies. So we saw earlier how when you actually compile an assembly, the reference gets baked into that assembly. A reference gets baked in about the dependents. Now that reference can be a strong reference to a thing that has a strong name, or it can be, for lack of a better term, a weak reference, a thing that doesn't have a strong name. Okay? A weak reference simply has an assembly name, no publisher key, no version, no culture. Let's assume you have a strong reference. Here's the mechanism we use to actually locate the assembly. First off, we apply version policy, which we didn't talk about at all yet, but we'll talk about that in the second half of this talk. So realize that this version policy gets applied before any of this happens. The first place we look, after we have a version that we're ready to bind to, we know we want this particular version of the assembly, we look in the global assembly cache. If we find that exact version in the global assembly cache, we load the assembly and everything's cool. If we don't find it in the global assembly cache, we look for a code base setting. I'll show you how to set the code base in just a minute. If we find a code base setting, okay, then we go and actually use that code base. If the code base is, if the assembly is found at that code base, we load it and everything's fine. If the assembly is not found at that code base, everything stops and the bind fails. Okay, so we don't find the assembly. So if you provide a code base, it's the last resort. There's nothing else that's going to happen after that code base if it's wrong. If we don't have a code base setting at all in that config file, we do some probing in the application directory. Now, this probing has kind of gotten a bad name, gotten a bad rep. We don't go grokking all over the application directory looking for things, okay? We look in very specific places. Of course, the first place we look is right in the application directory. So we'll look in a place that is, where'd my cursor go here? That I'm showing here is the app base. We look for a file with the name of the assembly.dll in the app base. Secondarily, we'll look for the assembly in a directory with the same name as the assembly, and a file is the same as that assembly name under the app base. So for example, if you're referring to foo, the assembly called foo, we'll look for foo.dll in the application directory. If we don't find that, we'll look for a directory called foo under the application directory with an assembly in it called foo.dll. That's the extent of the probing. There is some additional probing that goes on if you're looking for a specific culture of an assembly. So you can have the English version and the French version and the German version all installed in the same application directory and do probing under those directories if they exist. But it's not like we go looking all over the place in the application directory. We look for a file called foo.dll in the app directory. If that's not there, we look for a directory called foo, and we look for a file called foo.dll in that directory. And that's the extent of the probing. So if we find the application in those locations, we load it, or not the application, the assembly. If we find the assembly in that location using that probing mechanism, we load it. If we don't find it, there's one more alternative which I didn't mention earlier, and I will show you how to set this in just a minute. It's called the private bin path. This is probably not something that most people would use. It's more handy during development than anything else. But the private bin path is just a path that you can use. You can set per application to say, in addition to all the other places, look here. And we'll start probing on that bin path as well, looking for the assembly. And if we find it, we load it. If we don't, we fail. So there's quite a chain of locations we look for. Of course, the most performant is just to find the thing right in the GAC, and you avoid the probing, you avoid the code base, you avoid everything. A real handy utility for actually diagnosing this and kind of interrogating what's going on here is a thing called fuse log view, F-U-S-L-O-G-V-W. The Fusion log viewer logs all binding attempts. We call this Fusion because the mechanism for actually looking up things in the GAC and the thing that does this assembly resolution is a chunk of code that we call Fusion, or that's named Fusion. So this is the Fuse log viewer. It's a handy utility. Shows you the bind failures. I'll have a slide in a minute to show you some registry settings that you can set to actually turn on this viewing. So let's take a look at some things here. Let's look at some code. So what I have here is an application called WinLoan. I have 3 versions of it, and I have an assembly that is used by those called LoanLibCS. The LoanLibCS is written in C#. The WinLoan is written in VB. I have 3 versions of the library, the shared component, and I have 3 versions of the application. I'm going to go to the first version of the application. The application is written in VB, and I'm going to go to the bin directory. And you'll notice that I have LoanLibCS right next door to the exe. This is the deployed in the application directory model. Okay, let's take a look at this thing with a tool called the IL disassembler. This is the library, the shared library that I'm going to be using. Let me increase that font a little bit. Should have done that beforehand. If I look at the assembly, this lone lib assembly, I can look in the manifest, and the manifest will show me in here the public key that is actually used to sign that assembly. So I signed this and with a public key that I made up using that SN tool, and the actual public key is embedded in the assembly there. There's the public key. And I can also see the version number here. It says it's version 1.0. Okay. So now let's take a look at the executable with ILDASM, the executable that actually refers to that lone lib thing. You'll notice the executable is not signed. There's no public key in here. Remember I said that there's really no benefit to signing a non-shared thing. This executable is not shared. I didn't sign it. There's no benefit to that. The executable does have a version number though. It's not being used by anything, but there's a version number there nonetheless. But you'll see it has a bunch of references, or several references here, to other assemblies. It references things like MS Core Lib, it references Microsoft Visual Basic, it references system and system data and system drawing and WinForms, okay? And down the bottom here, you'll see that it references lone lib CS. Now at compile time, that reference was baked into this application, or this executable, by looking at the public key that was in the lone lib, pulling that out, generating a token for that public key, and this is the token. So we can see the public key token is right here, baked into this assembly. And it has the version number that I'm dependent on. So it says I'm dependent on a thing called lone lib CS that is signed with this public key and is using that version. So that's the one it's going to look for. Now, if I run this thing, it's a simple little application that calculates payments. So I give it some information and it calculates a payment. And I also, down here, just for grins, grab the version or the actual full assembly identity of the thing that got loaded. Okay, so I call into this lone lib thing, and I have a method on lone lib called getAssemblyInfo, and I actually display the version that got loaded. So I'm loading version 1.0 here, as I expected, because that's what I was referencing. And so in that case, it came right out of the application directory. Let's look at this one, version 2.0, or the application. If I look at, if I send this thing to ILDASM, I can see that it's dependent on lone lib version 2.0, right here, with the same public key token. Now, let's take a look at the global assembly cache. The global assembly cache is located in the Windows assembly directory. You can look at it just by browsing to that directory. There's a shell extension that we actually have installed that will show you the version, the public key, and the culture and the assembly name of all the assemblies installed in the global assembly cache. If we look in here, you'll see I have a thing called lone lib CS. It's version 2.0. It's in the GAC. Okay? There's no version 1.0 in the GAC, and there's no version 3.0 in the GAC. This is for an unrelated demo. Just ignore that one. This is the one we're talking about. So I run this one that's binding to version 2.0, and notice it loads version 2.0. That's coming out of the GAC. If we wanted to actually verify that was coming out of the GAC, we could use that fuse log viewer to actually see the binding, the probing and stuff that goes on to see that it came out of the GAC. I'm using version 2.0. In this particular example, with this app, what I added in version 2.0 is the ability to be able to calculate any of the other numbers. So the first one could only calculate payments. This one could calculate any of the others. Okay, that loaded version 2. Pardon me? You thought fuse log was only for failed binds. There's a slide in a minute I can, or at the end here, I'll show you how to turn it on for successful binds as well. So let's go to version 3 of this assembly, or this application. In this case, I'm binding to version 3. I won't show you an ILDASM. But I have another tool here that we actually created. This is actually a tool that we created for an interop demo. And what this tool does is it shows me the references on the property page for that particular assembly. So I can click on a managed assembly and I can see all the references. And I can see here that it's actually loading version or binding to version 3.0 of that particular assembly, lone lib CS. So if I run this one, what I might have the ability to do here now is calculate the payment and generate an amortization schedule. If you look down here, I loaded version 3.0. So where did version 3 come from? Well, if I look at this config file that's right alongside the application with the same name as the application and a .config extension, you'll see in here that it has a code base. I say code base for the assembly with the identity of LoanLibCS with this public key token. Version 3 of that thing can be found at this location. Okay, and I actually give it the location in my file system here of where that assembly can be loaded from. So in that case, I actually use the code base to actually find version 3 of the assembly. So those are all three mechanisms there of how each of where the assemblies can be stored. Okay. So that's what we call the default binding policy. We bind to the version we were built against. But often, or occasionally, that's not what you want. You want to be able to override that. You want to be able to customize that. And so let's talk about how you actually do that. The mechanism for actually locating an assembly, locating a physical DLL for a reference is what we call binding. So we have this reference in the assembly, and we actually need to find a physical DLL that we can load to satisfy that reference. That's what we call binding. And version policy is the mechanism for deciding which one of those assemblies will load in cases where we have multiple or where they can possibly come from different locations. And so we may have something like this, something that references LoanLib version 1.2.1.7, and we may have multiple versions in the global assembly cache. We may have a version of that assembly in the application directory. We may have a version of that assembly in some other place in the file system. We need to apply version policy to see exactly which one of those is going to get loaded. Now, the default binding mechanism binds to the version that you were built with all the time, okay? If you were built with version 2, you'll get version 2, regardless of whether there's 10 other versions installed on the machine, regardless of whether there's an English and a Spanish one, you get the one that you were built with. That's the default binding policy. We're able to do that because we have that identity of the dependent assemblies burned into the assembly at compile time, right? This is cool because it gives us, it allows us to make installation of other applications not impactful, right? One of the big problems we had with COM was that, I referenced some other DLL in the file system and everything was cool until somebody else came along and replaced that DLL and broke my application. In this particular model, if I'm referencing version 1, somebody else could come in and install version 1.1, version 2, version 10, and it means absolutely nothing to my application. My application will continue to bind to the version I was built with because the default binding policy indicates that's how the binding should be done. It requires the exact same name, publisher, version, and culture. If we don't find an assembly with meeting exactly that criteria, the bind will fail. And it prevents other publishers from replacing assemblies that I'm dependent on. So maybe I'm dependent on, I'm referencing a Sheridan grid control. Because that Sheridan grid control was bound with or signed with Sheridan's private key, there's no way that somebody else can go out there and install an assembly on the machine and claim to be the Sheridan grid control in place of that real control. So that's the default mechanism. We bind to exactly the version we were built with. Now there's ways to override that. There's three mechanisms that we provide. There's overrides per application, per assembly, and per machine. And these are typically done by different people in different scenarios. So let's look at what we call application policy. Application policy is the ability to be able to modify the binding rules for a single application. It only applies to this application that you're modifying. It's typically done by an administrator or by the person deploying the application. You can deploy it with a config file. For example, that WinLoan 3 that I just showed you, I could have deployed that config file right with my application. And so it's done by the developer or by the administrator. You can use a configuration tool that comes with the runtime for actually creating those config files. I'll show you that in a minute. Or if you love XML, you can hack all that out by hand like Don did on Monday. I think using the tool is a lot easier. I think you'll like the tool when you see it. Most people don't even know that the tool exists, so I'll show you that in just a minute. What the tool does is actually generate that config file for you. So it is just an XML configuration file. If you want to do it by hand, you can absolutely do that. You don't need to use the configuration tool or the admin tool to do that. The config file has to be located in the application directory. It's the config file that contains these redirects, and it's typically named with the name of the exe.config. So in the example I just had, it was winloanexe.config. In the case of web apps, it's called web.config, and it's in the bin directory for that web application. A little different naming mechanism. So what I have is an ability to use this tool. I'll show you the tool in a minute to set binding policy, and that actually generates a config file that gets stored in the application directory. The second way you have to modify policy is through publisher policy. Publisher policy is policy that would be provided by the publisher of the assembly. So if it's a Sheridan grid control or a Farpoint grid control, right, it would be the publisher of that particular assembly that would deploy this policy. And the policy would say, if you're using version 1 of this assembly, you should now start using version 2. It's really a statement about compatibility that that publisher is making. The publisher is saying, version 2 is directly compatible with version 1, and I'm willing to provide this policy to say that that's the case. And I'm willing to say that anybody that's binding to version 1 should now start binding to version 2. That's certainly something valid for the publisher to say. If anybody at all can say that, it's the publisher. And so we require that publishers sign the policy file that actually does this redirection. I'll show you how to do that in just a minute. So we prevent other people from providing publisher policy for assemblies that they didn't create. It has to be the publisher of that assembly that provides the publisher policy. Again, it's captured in an XML file. It's signed by the publisher to prevent spoofing. It can be deployed with an MSI into the GAC, just like the assembly that you're referencing can be deployed into the GAC. And the policy itself can be versioned. So a publisher today might say, if you're using version 1, start using version 2 when he deploys version 2. And then he deploys version 3, and he can deploy a new policy that says, if you're using version 2 or version 1, start using version 3. So he's actually versioning his publisher policy as he goes along. The publisher policy actually gets stored in the global assembly cache along with the other assemblies that it refers to. And the publisher policy can be overridden by the application policy. And not exactly overridden, but the application can state that it wants to ignore publisher policy. So I can have application policy that says, I want you to use this version regardless of what the publisher says. So we have kind of this back door so applications can ignore publisher policy. When a publisher provides publisher policy, he is altering the binding for all applications on that machine that refer to the old assembly, right? Because he's going to provide a redirection to the new version of the assembly, and that's going to apply to all applications that refer to it, except those that say to ignore publisher policy. So here's how you actually create a publisher policy. You can actually create a config file. The config file looks just like an application config file. You can actually just take an app config file and rename it, and then compile it with a tool called alink, specifying /link option, and you point to the config file. Specify the DLL that you want generated, and the DLL must follow this naming convention. It must be named policy.version major version minor .assembly name. Okay. You provide a key file to sign the policy with, the same key file that you use to sign your assembly, and you can give the version and the policy file or version as well. And so this is a mechanism to allow the publisher to redirect from one version to another. And the one last way to provide version policy is machine-wide. So let me back up 1 second. When you provide publisher policy, it's applied to all applications that bind to that particular assembly, right? So it's a somewhat global setting for that particular assembly. The last mechanism is to provide machine policy, and the machine is really the ultimate policy maker. This is a setting that would be done by an admin, and the admin's saying, you know, I don't care what the publisher says, I don't care what the application developer says, I want you to use this version, that's it, no questions asked. It overrides all other binding rules, all other policy, and it's typically a typical scenario where you would use this is for a security fix, right? You have a security bug in something. You don't want to wait for the publisher to give you a publisher policy. You don't want to go in and tweak every application on the machine. You just want to say, this version has a security problem, and so I'm going to redirect everybody from that version to the new version and make it take effect globally. It's actually captured in a file called machine.config, again another XML file. It's located in the version directory underneath Windows, Microsoft.NET frameworks config directory. So that's the directory where you can find that machine.config. Again, you can create all these or config files with the admin tool. So let's take a look at how this policy would actually work. I have an assembly here, or an application called MathLib. It has a reference to an assembly called AcmeLib, version 2.21.3.1. The default policy says, go and find me version 2.21.3.1. In the actual doing that, applying the version policy, the first place we'll look is in the application config file. So I may have an application policy that says, hey, if you're using version 2.21.3.1, I want you to start using version 2.25. And so that's the one that will get used after looking at the application policy. We'll now bind to AcmeLib version 2.25. I may then have publisher policy that says, hey, if you're using version 2.25 or referencing 2.25, I want you to start using 2.26. And so we'll get 2.26 instead. And lastly, the admin may come along and say, hey, I don't care what you're referencing. If it's between 2.25 or 2.26, I think there's a typo there, you should start using 2.27 because they both have a security hole, and you need to patch it with 2.27. And so ultimately you'll get 2.27. If any of those are missing along the line, we just use, if there's no machine config, we would just use the publisher policy. As I mentioned before, you can use this thing called the Fuse Log Viewer. It's a utility that ships in the SDK, handy for diagnosing bind failures. By default, logging is turned off with the Fusion Log Viewer. I can actually show you this tool right here. I won't actually walk through doing a binding, but to use the tool, you have to actually turn on log failures. Okay. In that case, it'll only log the failures that occur. So if we can't find the assembly anywhere, you'll see an entry in this Fusion Log Viewer, and then you can click on this actual entry, and it'll bring up text showing you all the places where we probed looking for the assembly. Couldn't find it here, couldn't find it in a GAC, looked in this directory, wasn't there. If you want to see all binding attempts, you need to set a registry setting. You can go into the registry and set, in the HKey Local Machine Software, Microsoft Fusion, you can set the fuse log value to 1, or create a new value underneath that key, fuse log, or force log, I'm sorry, force log equal to 1. That will log all binding attempts. You don't want to turn that on all the time, though. Logging, has some perf implications, and you don't even want to turn on the log failures unless you're trying to diagnose a problem. So keep that logging turned off until you actually encounter a problem. Okay. Time for a demo, I believe. Yeah. Let's go back to this VB loan thing. And the first thing I'm going to do is start the admin tool. Remember, I'm using version 1 here. This was the assembly that bound to version 1. And we ran it last time, and it got version 1 by default. First thing I want to show you here is, remember the last time in version 3, we used the codebase option to actually redirect, to actually point to where the codebase was. And I showed you the config file that was used. I can actually look at that configuration setting in the admin tool here. And I can see here, for this particular application, WinLoad VB, and it's the version 3 of the WinLoad VB, I have a codebase setting for the assembly called LoanLibCS. I'm telling it that version 3 can actually be found in that directory. So I could have come in here and created the codebase this way, or I could have just created that config file manually. Let me show you where the admin tool is. Most people don't even know it exists. You can go to Administrative Tools and go to .NET Frameworks Configuration Tool, and that will bring up this admin utility. The first thing you want to do if you want to set some policy for an application is add the application. So what I'll do here, and this application that I have here is the VB, the WinLoan VB version 3. So that's not the one I want to configure for starting here. I want to start by configuring the version 1 WinLoan. So I'm going to go out here and just point to the application that I want to configure. And so now I have WinLoan version 1. I can then configure some of the assemblies that it binds to. Right now you'll see none of them are configured. I can say I want to add an assembly to the configuration for this particular application. And I'm just going to say, show me all the assemblies that this thing binds to, and I'm going to pick which one I want to configure. So it'll go out and it'll show me all the assemblies that it binds to. It binds to system and system data. And down here in the list I see LoanLibCS, so I'll select that one. And now I can set the policy here. What I want to say is, if this thing binds to version 1.0, I want it to start binding to version 2.0. So I'm creating an application configuration setting or application policy here that actually redirects from version 1 to version 2. Okay? Now I go back here to my application. And where's version 2? Does anybody remember? It's in the GAC, right? So if I run this thing now, there's the config file it created. Let's take a look at the config file. The admin tool just created this thing. It says redirect old version 1.0 to new version 2.0. Okay? So if I run this app now, you see it binds to version 2.0. And 2.0 is compatible because this is a subset of the functionality that's in 2.0, so the app still works just fine. So that's how I would create config policy or application policy to redirect the bindings for one particular application. Let's take a look at how I would create publisher policy. Well, if I come up here to the LoanLib directory, I have 3 versions and I have a policy file here as well, or a policy directory. If we look in the policy directory, I have a config file here that looks real similar to the one I just showed you that was created for the application. It says redirect old version 1 to version 2. Oops, I think that one's, I want to change that. Oh, no, okay. So what I can do is, let's take a look at this make file that I have here. Oops. Yeah. Sorry about that. This make file that I have here that actually builds a publisher policy for me. So what I do is I use this tool called A-Link or AL, and I tell it to take that configuration file that I have right there and generate a policy for me called policy.1.0 .loanlib.cs or .loanlibcs.dll. Use this key file for signing it and make it version 1.0, and then use the GAC utility, the GAC util tool to actually put it in the GAC. Okay, so before I do that, what I want to do is come back here to this thing, and we just set the application config policy. I'm going to go in here and I'm going to delete this. Okay, so we no longer have app config policy for that. So now I'll go to V1. Run this thing, and I get version 1 again. Okay? So let's use the publisher policy that I just created. So I can take that thing and put it in the GAC using GAC util, but I think I'll just put it in the GAC. I'll take the policy file and just drag it right into the GAC. And so now I have in the GAC a policy file called policy.1.0.loanlib.cs. Now if I go back and run the same application, the version 1 app, it binds to 2. And remember, we just ran it a second ago. We got rid of that app config policy and where it told it to bind to 2. So now it's binding to 2 based on the publisher policy that the publisher just provided. That publisher policy was installed into the GAC next to the version 2 assembly. It was signed by the same publisher to make sure that nobody else is trying to be tricky with us here. And it actually caused this application, and in fact any other application that was binding to version 1 will now bind to version 2 automatically. So that was the publisher policy. Now let's suppose I want to say machine-wide, I want to set machine configuration policy that says anybody that's binding to version 2, I want you to start to bind to version 3. Well, the way I would do that is to use the admin tool up here and configure an assembly for the entire machine. So I'm going to go to My Computer, Configured Assemblies. Right now I have no configured assemblies. I'm going to choose an assembly from the GAC that I want to configure. And it shows me all the assemblies in the GAC. I'm going to go to this Lone Lab, CS. It's version 2. I'm going to select that thing. And now I'm going to provide some policy. I'm going to say, if you're using version 2, you should start using version 3. Everybody on the machine that's binding to version 2. In fact, I'm going to say, anybody that's using 1 through 2 should start using version 3. Okay? But there's a problem. Where is version 3? Does anybody remember? I used that code base before to point to it, right? So I have to actually point to it. Now, if version 3 was in the GAC, I could just get it right out of the GAC. It would just find it there. But what I'm going to do is come over here, oops, and get that directory that I had here. Okay, and go to configured assemblies here. So I have 1.0 to 2.0, go to version 3, and I'm going to say version 3.0 can be found at that location. Sorry about that. How are we doing for time here? Okay, I think I can make it. Okay, so now I set the binding policy for the entire machine to use version 3.0, and I gave it a code base where it can find version 3.0. Again, if it was in the GAC, I wouldn't have needed to provide that code base. I could have it would have just pulled it right out of the GAC. So let's go and run version 1 now. Keep your fingers crossed. All right. Let me run version 2 just to make sure. I must have had a typo here. Yeah, I did. File colon backslash system E3 again. Okay. Okay. Well, that's where fuse log would come in handy. So anyway, I must have a typo there in that code base. But by applying that machine-wide config policy, it would redirect all those versions to use version 3.0. And we can look at that config file in that directory, that version directory. So you'll just have to trust me that worked last night. So let me just jump back here. I have, I think, 1 or 2 more slides. Okay. So what a lot of this mechanism does is give you the ability to have side-by-side assemblies. So I can have version 1 and version 2 and version 3 out to version N all installed in the machine at the same time. And that sounds like a great thing. It's great because I can have all these applications binding to different versions. It's great because I can deploy fixes in an incremental fashion and redirect clients as necessary, only when it's appropriate. But there are some considerations that people need to be really aware of in building assemblies that are going to be used in a side-by-side fashion. For example, imagine I was running that WinLoan version 1 and WinLoan version 3 and at the same time, and one is binding to version 1.0 of the loan lib and one is binding to version 3.0 of that loan lib assembly. You need to consider that applications may be running simultaneously. And so if you're doing anything like using OS primitives, like using named resources or things like memory map files, or using a named event, for example, you need to make sure that those resources are version specific so that when you run your version 1 assembly next to your version 2 assembly or version 3 assembly, that you're not stepping on each other's resources, right? If you're writing to files, you want to make sure that the version 1 assembly writes to a different file than the version 2 assembly. Otherwise, when you run them side by side, they're going to be trying to write to the same file and overwriting each other's information. If you make registry settings, if you store your most recently used files, for example, in a registry, you want to make sure that you store them in a key that's versioned, so you can store them in under a V1 key, something like that, so that the V2 app doesn't get screwed up by the V1 settings and vice versa. Another important thing is that you want to consider uninstallation. So you want to make sure that these two things can work side by side, and you want to make sure that the user can uninstall version 1 of your assembly without breaking version 2. How would you do that? Very simply, creating a registry entry that's used by both of them, uninstall V1, and you just remove the registry entries that were used by V2, right? Create a file during install, uninstall V1, you delete the file, and now you broke V2 because the file that you depend on is not there. Maybe it's configuration information. So while side-by-side is really cool, really compelling, there are added considerations for developers when building assemblies that are going to be used in a side-by-side fashion. Don't forget about those. So what we should take away from this is those of you that are building components, sign your components, provide strong names, provide version numbers. By doing that, you make it possible for other application developers to use that thing in a side-by-side fashion. If you don't sign it, you really limit the ability of the application developer to service and to fix that assembly. So sign your shared code. Consider the GAC, the application directory, and code bases when actually deploying applications for application developers out there. They each have advantages and disadvantages. You can go through the slides here and understand each. And use application publisher and machine policy for actually providing a real flexible mechanism and customizing the binding semantics that you want for your particular application. And make sure you design your applications to support side by side.